Our institute and other research institutes in Europe are really concerned about the problem that society is facing nowadays, that it's related to environmental issues. The heavy use of fossil fuels worldwide is changing our atmosphere, so we should start some plans to stop this process. One way to face this problem would be to substitute fossil fuels by other type of fuels, energy vectors that are environmentally neutral. And one of these possibilities would arise from artificial photosynthesis.
And this is what the ALIF project is about, to convert solar energy into solar fuels. And for that, we needed to make a device. And we needed the input from all different expertises. So it's a really interdisciplinary project where we work together with people from chemistry, from physics, from material science, from engineering. And we got 8 million in funding from the European Commission to produce the prototype. So it has been already almost 4 years that we are collaborating, and we have the prototype almost ready for implementation.
In the ALIF prototype, the main idea that we like to have is the transformation of CO2 into useful chemicals, for instance, formic acid, or CO, or alkanes. And for that reason, we need to use catalysts that they are specific in order to do this transformation in a selective manner. So we need a prototype where we have different compartments where in each compartment happens one type of reaction. The first one that we find in the cell is the chamber where the CO2 is going to enter and exit, and it's going to encounter our catalyst. That's going to be located in this GDL, gas diffusion layer. Okay. Then we're going to have a membrane, and here we're going to have a liquid where the liquid products are going to be collected. Then we have another compartment which is separate also with another membrane that is not here in this device, but it's going to separate the compartment where the CO2 is transformed and the compartment where water oxidation occurs. Water oxidation is really important because it's the reaction we need to do in order to extract the electrons that we're going to use in order to do the CO2 reduction. And the catalysts that we're going to use in this prototype are based on iron and nickel, so it's really abundant materials. Then the device is closed, and on the top what we have is a photovoltaic cell that is going to collect the photons of the light, give us a redox potential that we are going to use in order to do those transformations. The interesting thing from this device also is that it is modular, so we can change the different parts, and it's easy, so we can easily upscale, but also allow us to study scientifically how this system works and how those components they operate all together.
It is not only a scientific challenge, we need to be able to do this process in such a way that it can actually compete with current fossil fuels prices. Otherwise, it will be very difficult to transform society and substitute fossil fuels if the price is not competitive with current technologies.
ALIF is also an opportunity for the PhD students and for postdocs, for a new generation of scientists, being trained in this interdisciplinary environment and being aware of the problem of sustainability. So I hope in the future, the generation of scientists that we are training will also have possibilities to develop these projects further.
Projects like ALIF, prototypes like the one we are going to introduce in a few months are just starting points in a long road to solve this crucial issue of fossil fuels for society and for environment. But projects like this one are fundamental if we want to find a real solution, a viable solution in the future.